And here we have one completed CANMIO without the chips in yet, and not looking too bad on the back with the soldering, having given it a clean off. So the next step will be to do the static voltage checks to make sure with power in nothing goes bang and that we've got the right voltages where the chips are going to go before we put the chips in. So what I'm going to do first is put the jumper links in that we need. So the CAN chip that I have is a 2562. The CANMIO can take a 2561 or 2562 depending on availability. And when you use a 2562, little jump link at the bottom should be in. It usually works if you get that wrong, but to be fully meeting the spec and working properly, that should be in. The next jumper link is power onto the daughter board, which I'm not currently fitting, so I can leave that off. There won't be power through this connector to a daughter board at the moment. That's something we can come to in due course. And then jumper link JP1, which is up here, sets the voltage that the second regulator is going to run at to provide power to the I/O. As I'm going to be driving servos, I'm going to set this to 5 volts. You could, in fact, do your static voltage checks with both, and we might even do that. So I'm going to set it to the H position. There's an H position, which is like this. That's the H position. And that means it'll give us as high as it can get out of the regulator with the 12 volts coming in. So you get about 10 volts or so out of that, which is quite good for driving various types of I/O independently from here. And that then comes down to this jumper link here. So this chooses, you've got 3 options, which you should be able to see there. You've got 5, 12, and R. R will be the output from the regulator. We're going to test all 3 as part of our static voltage check. So I'm going to start on 5. And that means it takes the voltage from the onboard 5-volt regulator, the 7805 here, and uses that to power the I/O. And we'll do the various checks. So taking my multimeter now, putting it on the volts DC range, and mine's auto ranging, but if you need to select a range, probably something around the 20-volt range as we're going to measure 5 volts and 12 volts. So the first place I'm looking for is the 2 pins here. I'll be checking the voltage. And of course, there's one little thing I need to do first that may have occurred to you. I need to plug in the power. Otherwise, nothing is going to work. Now, I happen to have a convenient C-bus cable here and a layout right next to me that's got C-bus on it, which is turned on. So I'm just plugging into that. And that means I have a standard C-bus here now with my 12 volts DC power. And I'm using red for plus 12, black for 0 volts, and I'm using pink and white for my C-bus CAN pair, which we're not using at this stage, just for this test. So I'm plugging it in, and you see the red LED, which looks slightly orange on the camera there, has come on to indicate that we do have some power on there. And now I'm just going to check the voltage. And I'm seeing 4.98. I'm actually seeing minus because I've got probes that way around. So the 2 pins, inner 2 pins of the CAN chip away from the connector, our power supply. And if you put the positive towards the top of the board, you should get 5 volts. I'm getting 4.98. I'll also check that on the PIC, which is pins 8 and 20. 8 for the negative, so I'll count down 1, 2, 3, 4, 5, 6, 7, 8. And it so happens 20 is just opposite one further down if you were to count it. And that's also 5 volts. So that's good. And then to check the I/O voltage, well, I can use a 0 volt reference from anywhere really, but I'm going to stick it on there, the connector. And various places I can check it. The middle pin with care of the servo header, and I'm seeing 4.98 volts, exactly the same as the main peak power supply, because I have my jumper in the 5 position at the moment. If I change that jumper now to the middle, which is actually labeled 12, it's sort of nominally 12. In actual fact, I'll get, as I mentioned earlier, the highest it can get to, and I'm getting nothing, so something's not right there. Actually, the other thing I haven't done is put my pull-up jumper on, but that doesn't actually matter for the purposes of what I'm trying to measure here, I don't think. Let's just check what we're getting here. So my regulator, second regulator, doesn't seem to be outputting, so that's something I'll have to check into and debug. Let's just make sure it's not just finger trouble. I'm going to move this jumper. No, sorry, that's the 12 volt. Deliberate mistake. Remember I mentioned earlier in the build that we can either put our IO power in through here, or we can put a jumper link on there. And I've done neither, which kind of explains why I'm not getting any output. So I need to find another jumper link. Should have a couple to hand. So I'm going to put a jumper link on the auxiliary power jumper link there. See how that does squeeze on nicely enough with the connector in place. And while I'm at it, because it's the best, usually best option for driving servos, this 3-pin jumper link here is labeled up and done. And we're going to have that's for pull up or pull down on the MIO. I'm going to set that to high, pull up through the servo outputs. And now I'll try again measuring my voltage. Here we go. Now I'll just pop that on the power pin in the middle of the servo. And now I'm getting 11.6, which actually is quite good through with the voltage drop through the regulator. So that should be the 12 volts that I'm getting in, less one Schottky diode drop. And if I go to what I'm getting in, I'm getting 11.9, 0.3 of a volt drop. That's not unreasonable. So now I'm going to move the jumper link to the third option position, which is I'm now getting power from the LM317 regulator. So I'll use that as my ground reference again. Check what I've got. I've got 9.56, so that's as good as the regulator can cope with the voltage drop through the diode and the regulator for what we call the H voltage. And that's that option in the regulator. I can now change the regulator jumper to the second position on there, which is labeled 5. So that regulator should now be producing 5 volts, which is what I will use to drive my servos, and indeed 5.03. And I can tell it's different from the onboard 5 volt because that was 4.95. They're both within acceptable range, but that proves it's coming from a different source. And having the servos driven from their own separate regulator helps to isolate noise in both directions between the digital circuitry and the servos. And on a layout with a lot of servos, if you don't want to load the C-bus 12 volt supply with all of that servo power, you can have a separate supply around the layout for your servos, separate 12 volts, and feed it in through here, which is dropped in each board through its own regulator to 5 volts. So I'm happy with the static voltage checks, and I've done them in the order so that the boards end up left in the way I want it to be. So now I can fit the chips. So important to do anti-static when working with the chips. The CAN chip is known to be particularly susceptible to static voltage problems. Yeah, so I've got anti-static strap, and now I'm safe to handle the chips. So I'm going to start with the CAN chip. 2562. Now, as we commented earlier, the notch is on the bottom, so the dot on the chip goes to the bottom. And chips as they are supplied have the legs a little splayed out, and that's for the automatic machines that would assemble those in an automated factory. We're doing it by hand, and if you won't go straight down in because of the splay on the chips. Now, different people have different techniques. You can get special bits of kit. What I tend to do, clumsily failing to do it for the camera, making sure it's the right way around, is that I will put one side in and just very carefully ease it across until the second side matches. Sometimes you might jiggle that backwards and forwards. Once they're all nicely lined up, I can just pop that down. And that's that one in. Then we've got the pick. This is an 18F26K80, so it has enough memory to run the latest CANMIO universal firmware, which is what I'll be using in this board. So again, I'm going to pop it in, put a little bit of gentle pressure. You just have to get the feel for that. And then I'm probably going to do the same the other way. And that just gently eases the pins in. Do too much pressure, you'll bend the pins. Some will do it on the side of the workbench or whatever. I find for me, it works nicely that way. Double checking the notch and pin 1 are at the top. And that one goes in. Now this socket here, you've got two options. I've got both here. One's just a resistor pack, 1K resistor across each of the 8 I/O lines, which is what we need for driving servos and doing inputs. Or we can fit a driver chip, which actually will power for outputs if you need more than the PIC can give in terms of voltage or current. So for my application today, I'm just going to put the resistor pack in. Now, the resistor pack isn't supplied with power, so it doesn't use the bottom 2 pins, which are also used by the driver chip. So I put it aligned to the top and leave the 2 pins not used at the bottom. Same technique for that one I'm using. And that's also now in. So that's all my chips in. Now what I've got here is an RME kit. Now we program the PICs as they go out the door, so that the purchaser can specify the firmware, and we know we've got the latest. Merg kits are generally done by the ELF, and so your Merg kit will always be pre-programmed. So will your RME kit for whichever module you buy. However, I've just grabbed this from stock and haven't programmed the PIC. So what we'll find is, in my case, I won't get any indication when I plug it on because I've got to program the PIC. So I still get the red light, but nothing's getting, we just check that nothing's getting hot. The regulators aren't getting hot. No, none of the capacitors have gone bang. So that's all good signs. And we haven't got the green or yellow on because we haven't got a program inside the PIC yet. With your kit, you would normally expect to see the green LED come on to indicate that the program inside the PIC is running. So we've got a separate video about programming PICs. So I shall now magically go and get that done. And we'll just check that it's running. And so with the PIC programmed with the, in this particular case, it's got the CANMIO universal firmware in it. So I should now just be able to plug in. So we can see we've got a green light, and that means that the PIC is running, and we're currently in so-called slim mode. So what I will do, just as an initial test, I'm not going to set it up right now, but if I hold down the little push button until the green light starts flashing, apologies, the yellow light starts flashing. In order to do that, it actually has sent a message onto the C bus. So that means that that communication is working. So that's a little test. Obviously, further testing will be done when we actually configure it and set it up into Flim. So if I press the button again now, yellow light goes out and we're back just into the startup slim mode. So that's looking good and is ready for action. And another little check that you can see, I have to angle it for the camera to actually be able to see it. If you've got it connected to an active C bus where there's some messages going back and forth, you will actually see the yellow LED should flash. This is CANMIO universal only, I should add. It's not on the CANMIO server only firmware. There you can just about see that it's about every 5 seconds. That's because I've got a loco selected on the layout and the handset is sending its keep alive every 5 seconds. But whenever there's C bus messages going on, it acts as a little activity monitor. So that's the end of the CANMIO build video showing you how to assemble a CANMIO. I think overall the actual build time was less than an hour. Maybe the whole video is more than that with all the other comments and so on. I've done it kind of in real time rather than using time lapse. You can always fast forward if you don't want to see all the nitty gritty detail of every single solder joint. And come back for more. I'll be doing a video on filter boards and a video on using the CANMIO as well as building other modules. Bye for now.